All right, ladies and gentlemen, today we're going to look at section 7.4 in our book. And if you look, it's entitled Fractional Equations. Now, there's that word fraction again. Remember, we're in chapter 7. Chapter 7 is showing us how to apply fractions. And so let's look what it says our definition is. It says a fractional equation is an equation with a variable in the denominator of one or more of the terms. To solve a fractional equation, we multiply both sides of the equation by the LCD. Now, if you read through that, you're going to say, yeah, but Mrs. Burton, that's what we did last night, and that's true. Whenever I look at an equation and I want to solve that equation, and it's got all those fractions in it, elimination is still the way to go. We want to get rid of all those fractions by multiplying by the LCD. Now, again, the thing that's different today is that there's going to be a letter in a denominator somewhere. So, if I look here then, I've got to decide, if I have 6 and x and 3, what's my LCD going to be? Well, it's a number thing and a letter thing. Between 6 and 3, what are we going to choose? 6. And the only letter there is x. So remember, everybody comes to the party. So my LCD is 6x. Now, we're going to see that we have a little shortcut. It doesn't work all the time, but when it does, it's pretty nice. It says when an equation consists of one fraction equals another, we can solve using cross products. Hey guys, this is a fraction equals a fraction, and that's a proportion. As long as I have a fraction equals a fraction, then I can solve it like a proportion, and I can cross multiply. So now that we've kind of got those little facts in our head, let's look at the problems and see what we can do with them. So let's go ahead. Everybody copy down equation number 1. So if I look at equation number 1, the one I just copied off of the first slide, we want to add. And again, as soon as I look and see that I have multiple fractions, elimination. I want to eliminate those fractions so I can solve that equation. So if I look there, okay, what is my LCD going to be? Well, remember we said we've got numbers and letters. So between 6 and 3, we're going to multiply by 6. That's my least common multiple. And there's only one x, and so x is going to have to come along for the ride. All right, so now I need to multiply all 3 fractions by 6x. So let's see what happens when I do that. All right, if we multiply by, put my 6x here, then the 6's are going to cancel, and we're left with an x. And then if I multiply the second fraction by 6x, the x's are going to cancel, and we're going to have 12. And if I multiply, I got to put my equal sign. And then if we multiply the last fraction by 6x, well, then we're going to have, this is going to be 1, we're going to have 4x. Everybody understand where that came from? All right, so now, presto changeo, fractions are gone. Okay, fractions are gone. Now we're just going to solve for x. Isolate the variable by inverse operations. Okay. So, all right, I'm going to move this x over. Remember, I'm going to put x's on one side, numbers on the other. So now I have 12 equals 4x minus x is 3x. Hopefully everybody realized x equals 4. Now, let's go back a few chapters. What do I have to remember to do if I have a variable in the denominator? Ooh, do you remember that? If we had a variable in the denominator, then we had to come up with restrictions. Remember, what are restrictions? What can the denominator not be? That's right, we learned that the denominator cannot be 0. If the denominator's 0, then it's undefined. And so when I look up there, I do have this little x all by his lonesome, okay, in the denominator. So x equals 0, but my restriction is x cannot equal 0. Because if I plug in a 0 for this x right there, then that makes it undefined. So that's the kind of hard part. We have to go back and think about this idea of restrictions. And the reason we have to do that is because we have letters inside or in the denominator. All right? Now, let's look at number 2. This is exactly the one off the first slide. And as soon as you realize, hey, I've got a fraction equals a fraction, when you realize that, we can solve this as a proportion. Remember, we've got the means equals the extremes from yesterday. And so we could say b times 3 plus b equals 2b times 1 is 2b. Okay, so now what do I need to do? Okay, we're solving. I got to take care of that distributive property. So we've got 3b plus b times b is b squared equals 2b. Did you notice I have a quadratic equation? Ooh, chapter 5, we got something squared. Whenever we're trying to solve an equation that has a quadratic term in it, remember, what does it have to equal? That's right, this has to equal 0. So I'm going to subtract 2b to the other side, and I'm going to go ahead and put it in standard form. So remember, I need my quadratic term, and then 3b minus 2b is 1b equals 0. So again, as soon as you realize, oh, I've got b squared, I've got x squared, as soon as you realize you've got that quadratic term, ooh, we go back into chapter 5 mode. How do I solve a quadratic equation? It's got to be in standard form, and it's got to equal 0. So here we are. We're in standard form, and we equal 0. So what do? How do we make it equal 0? So remember, we've got to solve. We look at it and we say, oh, can I factor something? Do you realize I got a GCF? So I'm going to factor out the b, and I'm left with b plus 1 equals 0. So after we factor and it equals 0, do you remember what we do next? Nice, good job. We're going to use zero product property, ZPP, which says if the whole thing equals 0, then each part equals 0. So this first b out in front, he's going to equal 0. And then the second part in the parentheses, that's going to equal 0. And if I solve for the second b, we're going to get b equals -1. Okay, now, so we've solved. We've got b equals 0 and b equals -1. Now we have a little bit of a problem. Does anybody see the problem? Yeah, we've got b in the denominator, and right here we said that b equals 0. What's the problem with that? If I plug this b in, I'm going to get 0 in the denominator, and that can't happen. So we're going to actually reject this answer, okay? We're going to reject it. We're going to say b equals 1, and then the restriction that you're going to give me is b cannot equal 0. Okay, so we're going to go back and look a lot at some things that we learned back in chapter 5, at the end of chapter 5. Okay, let's try another one. Let's everybody go ahead and let's copy down number 3. Let's copy number 3. So when I look there, okay, can I solve it as a proportion, or do I need to multiply by the LCD? Nice. Because I have a fraction equals a fraction, we can cross multiply. We can use our cross multiplying plan and use it to solve this problem. All right, so here we go. I'm going to go this way. 4 times 5y minus 1 equals, and here we go, 1 times that is 1 minus 5y. So we did our cross multiplying. Now what do we need to do? Yeah, let's take care of our distributive property over here. So 4 times 5y is 20y minus 4 equals 1 minus 5y. That looks a lot like some things we did yesterday. I've got letters on both sides, so we need to isolate the variable by inverse operation. So I'm going to go this way. I'm going to add 5y to both sides. So I have 25y minus 4 equals 1. All right, and now my floater is this 4, so I'm going to add 4 to both sides. So I have 25y equals 5. And hopefully you realize we're dividing both sides by 25. So we have y equals 1/5 when I reduce that fraction. Okay, so we solve for y, but now we've got to check it out. Because I have that variable, let me go ahead and erase this so you can see what's going on. Now, because I have that variable in the denominator, we've got to check restrictions, okay? Are there any restrictions? And again, we're going to see when I do that, yes, there is, because I have a variable in the denominator. Now, if you remember from chapter 5, I said the easiest way to find your restriction is to take that binomial and make it not equal 0. And we're going to see when I solve for y there, y cannot equal 1/5. Well, guess what my answer was when I did the math? 1/5. So guess what? If y cannot equal 1/5 and my answer is 1/5, this guy right here is going to be no solution. So that's why it's real important to check those restrictions. And again, we only worry about restrictions when I have a variable in the denominator. Now, here we go. Let's talk about what happens when I have binomials. Okay, now we looked at this a little bit back in chapter 6, I think. So when I look at number 4, now I'm supposed to solve for n. Now, am I going to have to use, can I use cross multiplication, or am I going to have to multiply by the LCD? Yeah, did you realize this isn't a fraction equals a fraction, so we're going to have to multiply by the LCD. So now, to figure out my LCD, remember we have to factor those denominators to get there. Well, n plus 2 is about all I can do there, n plus 2. But when I look at the n squared minus 4, n squared minus 4, remember, what is that? What special pattern is that? Difference of perfect squares. So remember, this is going to become n plus 2, n minus 2. So now, what are we going to choose to be our common denominator? Well, remember what's common to both. Well, n plus 2 is common to both, so that's going to be part of our LCD. And then what was my line? Everybody else comes to the party, so we're going to have to bring this n minus 2 along as well. So my common denominator then is n plus 2, n minus 2. Now, let's see what happens when I multiply those. So if I look at my first fraction, the n plus 2's are going to cancel, so I've got to multiply the numerator by, and it's going to be n plus 1 times n minus 2. Minus, and if I go to the second fraction right here, well, we actually have the right denominator, so both of these would cancel out, and we're just left with minus 10 equals, and then 0 times that is 0. I know, kind of long and drawn out, kind of complicated. Now, when I have a binomial times a binomial, what do you think I'm going to have to do? That's right, I'm going to have to FOIL that. I'm going to have to FOIL that. So if we FOIL this, remember we've got FOIL, which means first, n times n is n squared. Outside is n times negative 2, which is negative 2n. Inside is 1n, and last is negative 2. We're going to take the middle and combine like terms. So I've got n squared minus n minus 2 minus 10 equals 0. Now, hopefully you saw I got some like terms right here we can put together. So now I've got n squared minus n minus 12 equals 0. Oh, we have a quadratic equation. How do I know it's quadratic? because of that n squared right there. How do we solve a quadratic equation? That's good. Well, it's in standard form. Okay, so we're already in the right form. Standard form is done. Okay, and it already equals 0. So where do we go from here? Do you remember? We just did it a second ago. Yes, I'm going to have to x factor that. I'm going to have to x factor that equation. Okay, I'm going to have to x factor that equation. And here we go. So we've got n and n. If we look at my signs, one needs to be plus and one needs to be minus. Okay, I need factors of 12. That'll somehow give me 1, so we're going to do -4 and +3. Does that look familiar? Of course it does. All right. Okay, so let's go ahead. Remember, if the whole thing equals 0, each part equals 0. So now we've got n plus 3 equals 0 and n minus 4 equals 0. So here n equals -3, and on this side n equals 4. And now, because we have letters in the denominator, we need restrictions as well. So I took my denominator, made it not equal 0, so n cannot be 2 or -2. So my answers are this, okay, and then my restrictions are this. N cannot equal 2, n cannot equal -2. So we're putting a lot of things back in from chapter 5 that we learned, all right? Okay, let's go ahead then and look at our next slide. Okay, a lot of important things coming back from chapter 5. I hope you're remembering. So when I look at number 6, okay, definitely adding and subtracting. I've got z's in the denominator, so we need to solve. So what are we going to, my question is, do I have to multiply by the LCD or can I use cross multiplying? Right, we're going to have to multiply by the LCD. Now, so that means I've got to look at my denominators and factor if I can. Well, this first denominator, I can't do anything. But did you see the back denominator has a GCF? If we factor out a 3, what are we left with? 3 minus z. Okay. Ooh, do you see something? Do you remember what we call z minus 3 and 3 minus z? Very nice. Yes, those are opposites, okay? But, okay, so in order to take care of opposites, remember our opposites, how do we take care of opposites when we deal with them? Yeah, nice. Remember that -1 thing, all right? So that means that my common denominator that we're going to multiply everything by is going to be 3 times z minus 3, all right? Now, so if I multiply the first fraction times my LCD, the z minus 3's are going to cancel, so we've got 1 times 3 is 3. Remember, because we took care of the opposites, this plus sign right here is going to become a minus sign. And when I take the second fraction and multiply by the LCD, all right, remember everything's going to cancel out because I have the right common denominator. So this is going to be 3, and then we've got equals 0. So when I look there and we do the math, what's 3 minus 3? Well, 3 minus 3 is 0. Does 0 equal 0? It does. What happens when we get a true statement? Do you remember back in chapter 5? Yeah, identity. Or the other thing we said was the answer could be all real numbers. Remember my little symbol for real numbers? Yes. Good job. So a lot of chapter 5 are coming back. Now, am I going to have restrictions on this problem? I sure am, because there's letters in the denominator. So there's my restrictions, okay? So I take each part, z minus 3. It cannot equal 0. So when I solve, z cannot equal 3. And then there's the second half, okay? All right, let's do one story problem, and then I'm going to let you go ahead and start on homework. So let's go ahead to the last slide for today, and here we go. It says, the sum of a number and its reciprocal is 13 over 6. Write and solve an equation to find the number. So, again, our 5-step plan, so we know we need to find a number. Okay, so our let statement has to be let n equal the number. Okay, so n equals the number, and so now I need my equation. Well, it says the sum. Well, if it says sum, we know we're using addition of a number and its reciprocal. So how are we going to write that? Yeah, we've got the number, which is n, plus its reciprocal, which is going to be 1 over n, equals is, remember, is means equal, 13 over 6. Does that make sense? All right, so now, how are we going to solve this problem? Oh my goodness, I've got fractions. How do we solve an equation with fractions? Elimination. So if I look here then, what would I choose to be my common denominator to multiply everything by? Well, and again, this little n here is going to be n over 1. So we're going to multiply by 6 and n. Everybody understand? All right, so here we go. Here's what happens. If I multiply n by 6n, we get 6n squared, plus, if I look at this, the n's are going to cancel, and we're going to get 6 equals, okay, and then over here, the 6's will cancel, and we're left with 13n. Ooh, look at that. Did you notice right away that we have a quadratic equation? We've got n squared. Okay, so in order for me to solve a quadratic equation, remember, it's got to be in standard form. Is that in standard form? No way. And it equals 0. So, hopefully you realize we're going to have to subtract 13n. But I'm going to bring him over here and plop him in where he belongs and make it equal 0. Remember, we need our quadratic term in the front. Okay, quadratic term, linear terms in the middle, constant terms on the end, the number that's all by his lonesome, and it equals 0. Now, what do we need to do? Yes, we need to factor that. Okay, so X factor is the way to go because there's no GCF. So remember, we need the factors of 6, which are what? 2 and 3. What are my factors of n squared? N, n, n. Let's look at our signs. If we look at our signs, the first one is minus and the second one is plus. So we worked on our sign chart, and that means both of these need to be minus. Okay, so now we need factors of 6. Now we need a 13 in the middle. We need a 13 in the middle. So do you think, are we going to use 2 and 3? So for 6, are we going to use 2 and 3? Or are we going to use 1 and 6? Yeah, I agree. 1 and 6, 6 is too big. So we need to use 2 and 3. So let's figure out where we're going to place them. So we need 13 in the middle. So we've got 3. Okay, so if we put a 3 here and a 2 there, let's X factor and check the middle and see if it works. Remember, we've got, this is going to be negative 4n, and this is going to be negative 9n. Hey, guess what? We have chosen wisely. Okay, so that means we have 2n minus 3, 3n minus 2 equals 0. Okay, if the whole thing equals 0, each part equals 0. So here we go. That means we've got 2n minus 3 equals 0, and 3n minus 2 equals 0. Yep, we're going to add 3, so we've got 2n equals 3, so n equals 3 halves. And then over here, we're going to add 2, so we've got 3n equals 2, so n equals 2 thirds. And now we've got to check. Are we going to have a restriction? Yeah, did you notice we have an n in the denominator? So we're going to say n cannot equal 0. All right, great job. I'm going to let you go ahead and start working on homework.